Tricky Topics video series. Hippocampus and memory. The hippocampus is found in all vertebrate species and has an important role in memory. In primates, like us humans, the hippocampus is located in the medial temporal lobes. The red circles in this image show the original location of the medial temporal lobes in the brain of famous amnesia patient Henry Molaison, or HM. In fact, he had this area of the brain surgically removed, and the unique memory problems that followed shed light about its importance in specific memory processes. HM's memory was famously studied by neuroscientist Brenda Milner, who for decades worked with him as a research participant. The photos on the left were taken around the time they first met, and those on the right are from 50 years later. Milner used different types of cognitive tests to show that HM had selective amnesia. Although his pre-surgery memories were intact, he couldn't form any new explicit memories. In fact, despite their long-term collaboration, HM could never remember meeting Dr. Milner, showing the profound nature of his amnesia. Although HM could not lay down any new explicit memories, he could learn new implicit tasks, like the mirror tracing task shown here, where you have to trace between the lines of this image by looking at your hand with a mirror. Although he had no recollection of doing it, his performance improved over several days, indicating that he had formed a new memory. HM lost many structures in the medial temporal lobe, including the hippocampus, amygdala, and large parts of the rhinal cortex. In HM's case, it's impossible to determine which of these structures had specific roles in his memory problems, so researchers often use these studies as a starting point for other research. Ablation studies in non-human animal models allow researchers to control the location and timing of damage with specific lesions. Language-based tasks of declarative memory in humans don't work well in non-human animal models. We can't ask laboratory rodents about their explicit memories like we can with HM, so researchers use nonverbal tasks like the Morris water maze shown here. In order to find the hidden platform, rats must form an explicit memory of a spatial location from previous trials, shown by the dashed white line. If they form a strong memory of the location after training, they'll take less time and distance to reach the platform, shown by the dotted yellow line. In this study, rats were trained to find the location of a hidden platform in the Morris water maze. They did this either before surgery, shown on the top, or after, shown on the bottom. The surgery involved either a hippocampal lesion or a control procedure without damage. That way, researchers could separate encoding and retrieval processes and examine what happens with or without a functioning hippocampus. There are a couple of different ways to measure memory on the water maze. The simplest is to see how long it takes to find the platform. However, if you want to look at the strength of a memory, then you can remove the platform on the test trial and time how long the rats spend in the area where the platform should be. This black area here shows the previous location of the platform, so a rat that has formed a memory of this should spend most of its time here. So what happens if the hippocampus is lesioned after training, when the location is already learned? What if the hippocampus is damaged first, before training? This figure shows the average time spent in each zone, represented as percentage time on the y-axis on the left. The pattern in the diagram on the far left matches the bars in the graph. Since the platform was in the black zone, we'd expect the black bar to be the biggest if the rats remembered where the platform was supposed to be. The bars on the left show time spent for animals that were first trained on the water maze to find the hidden platform, then had either a sham surgery as a control or a hippocampal lesion. When they were tested for their memory of the platform on the test trial, they both spent most of their time in the correct zone, shown by the black bars. So if the lesion was done after they already learned the location, there was little difference between the control and lesion animals. However, if the surgery was done first, shown by the bars on the right, there was a difference between the groups. The sham control rats spent most of their time in the correct zone, as expected. But the lesioned animals didn't seem to know where it was. If you take a look at their swim paths, it's clear that the lesioned animals seem to be searching at random. Keep in mind that HM, who was also missing his hippocampus, could retrieve his stored explicit memories but couldn't form new ones. These results show that the hippocampus supports encoding of new spatial memories in rats, but not retrieval of previously stored ones. If a location is important and we need to know about it in the future, the hippocampus makes sure we can create a memory of this place, but is not involved in recalling it.